Bismillahirrahmanirrahim. So we covered requirement modeling techniques, requirement gathering techniques, and now we are covering data modeling. Data modeling, we discussed that it's a relationship or constraints between or among the data. So data modeling is used to describe the relations or constraints. Constraints mean dependencies between or among the data. And we have schema architecture. We call it database architecture. So front-end architecture, data flow diagrams or the UML use cases, class diagram, sequence diagram, that is done. Now we are covering the back-end architecture. And we have three types of schema architecture. We have logical or conceptual schema. We have internal or physical schema. Logical, internal, and external. Logical is called conceptual, internal is called physical, external is called user view. External, it is for environment. At the logical schema, any idea? Front end, we have structured modeling and we have object-oriented modeling. So that means we have structured analysis and we have object-oriented analysis. For structured, we'll draw data flow diagrams for the front-end architecture. So for the back-end architecture, we have ERD and normalization. ERD and normalization. This is for structure, and we are covering analysis phase techniques. And ERD is only done for structure and at the analysis level. Normalization we do in design techniques, in design phase, because we are at the analysis level. And this for structure. And if we have OO, object-oriented, then how we do data modeling? At class diagram or object diagram, we will define the relations between them. One-to-one, one-to-many, many-to-many. The difference is only labeling. In ERD, you have no foot and you have and symbol, but in class diagram you have star symbol to represent, or you can have like one, many, but if you can want to specify number of objects, you can. Like in this section we have 11 students for 251, so we can have 1 to 11 students. Number of objects, exactly number of objects we can specify, that's in the class diagram. So for object-oriented, we can have class diagram or object diagram. Class or object.
Doctor, is class diagram and object diagram are a different thing, or?
They are different. Class has objects. Like course, class. Course has objects CPIT 251, 250, 252, 455, 456. These are the objects. Student is class. Student objects, your ID, your name. You are an object of student class.
So we can't do the object diagram if we don't have the class diagram, or?
It's up to you or the company where you are working. Or like you are doing your capstone project 498, 499. What are the requirements by the committee or the supervisor? As far as my experience, I visited almost 100 plus companies. They don't have time to do all these diagrams. What they do, they draw use case or not and or class diagram or sequence diagram or sometimes use case class, that's it. I ask them why? We don't have time and we are so professionals, we are working in this industry from so many years. It's enough for us and it is enough for the programmer to write the code. But whatever the diagram you draw, it should be complete in all aspects. Then no more confusion, no more ambiguity. So programmer doesn't need to ask to the architect which class is associated with this class, which object is calling this, what are the data, what are the methods, what are the actors. Should be very clear. Like use case. One of the companies, they have project in USA, its name was Descon Infosys. And they have a project for an American company and project name was great because it was an ERP system for a property estate company. You know property estate companies which buy and sell the properties as middlemen like state agents. But this company was very large company. They have offices in 50 states of US. And real estate.com. And they have in USA, in Australia also. In Australia, they have website .au, realestate.com.au, and they are operating in USA as well. USA 50 states, they have offices. So they need an ERP system. They have use case diagram only and use case description. Use case with use case description, 2 pages use case description. Use case diagram, for each use case, 2 pages use case description. It was so complete and I saw normally they don't show to external people. But because I have Vasta reference, the project manager I know, so his name still I remember, Howard, now he's in USA. So Howard showed me 2 pages use case description for each use case. So complete. After that, programmer doesn't need to ask what are the data, what are the functions, what are the actors. It's very clear. Because no time to ask again and again. And confusion means you will do mistake in coding. You will do wrong code, then you have to correct it. And then errors, bugs will come and wastage of time.
Why do you use the use case specifically? Isn't the class diagram more accurate or and easy for the programmer?
Because they are comfortable. As I told you, the company policy or the project manager in which he has experience, in which he is comfortable, and customer is agreed. Because you have to give this documentation to the customer. If customer is happy, I don't have any problem. That's fine. Let it go. So it depends upon company to company, what policy, what strategy they have, or the project manager, how much he is comfortable in which. If he is comfortable in use case, he will do that. If he is comfortable in class diagram, he will use that. If he is comfortable in sequence diagram, in which you are master. In which you are master to show the architecture. Because programmer needs very clear-cut architecture. In which architect, we have architect job, system architect, in which he is comfortable. Or the company ask him to do that. But whatever the diagram, it can be class in some companies have sequence, but it should be comprehensive, it should be complete in all aspects. No more ambiguity, no mistake. And they don't have time to sit on a table and use some tool like star UML or rational rows. the practically architect will use paper, pencil, rough. He will do that because requirements are coming. He will do that, ask the programmer to do this, implement, and there is a guy, documentation guy. Normally females love this job, the documentation part. So that documentation guy will make it neat and clean to have the proper documentation, system documentation later on. But run time, they will use rough paper, pencil, dry. So we covered the logical part, ERD for structure and for object-oriented class diagram or object diagram, to define the relations between them, to describe the architecture, backend architecture. Any question? Now that we covered the analysis phase techniques, done. Requirements gathering, done. Requirements modeling, done. Data modeling, now we move to design phase techniques. As the schema, logical schema, normalization is done at the design level. So, normalization is for schema, logical schema or conceptual schema. What is normalization?
Getting rid of useless information in diagram, maybe.
Normalization. Never heard.
We think it's in database.
Then we are talking about schema, the backend architecture, database architecture. Normalization is a process to convert complex data structure into simple and stable data structure. Transform complex data structure into simple and stable. So no more duplication, no more redundancy. Application of data, duplication of data. And remove the dependencies among them. Like ERD, if you have many relations, association will become a table.
Your relation.
So remove the dependency. Like we have primary key and foreign key concept. A non-key is depending more than 2 attributes. Make a separate table. Remove the dependency, because I'm not going in depth of this. I'm just touching, because I'm covering technique, not this content. This is this separate course, database course is doing. So I'm just touch and go, just to refresh. And we have how many normal forms are there? I told you, objective of this session is not to ask that student who knows. Objective of this session is to ask that student who doesn't know. So psychologically, if you don't know anything and it is asked you will be attentive to listen and remember. This is human psychology. So I try to deal with that. Yes, 3.
What we learned is 3, but I think there is more.
Up to 5. We have first normal, second normal form, third normal form, BCNF, voice code normal form, fourth normal form, fifth normal form. But normally we don't go up to fifth normal form. We normally go up to third normal form, as he said 3. Up to 3 we normally do. When we are doing the documentation, up to 3, because it's enough for us. We have removed dependencies. And up to fifth normal form, so much normalized that you have to denormalize, you have to make it some dependency, that it's totally independent. And we don't want to have totally independent tables. We want to have joins among them so we can generate views, the external view, to have some connection between them so we can call data from multiple tables. Otherwise it will be solo tables. No relations. And we are doing relations. We are doing data modeling, establish the relations. We don't want to kill the relations. So making it so simple that it's totally rubbish. We cannot use that. So that's the schema, logical schema done. And then we have internal. What is the meaning of internal? Once we have done, yes, there is a question. For structured, we do normalization. But for object-oriented, do we perform normalization? Remember, there is always logic behind it. Reason. Like I'm teaching you using analogical reasoning. Reason by example. So I link my topic with some example, with some application to make it understandable for you that where this concept is used, where this concept is implemented, in which application or which part of software engineering. Anybody? Do we perform normalization in object-oriented? Why not?
No, I don't know.
You don't know. Yes.
I don't think so because it's already normalized.
Yes. Because objects are already normalized. What is normalization? To convert complex data structure into simple and stable, and objects are already stable. They are already unique. They are already unique like you. You are unique. Employee unique. Vehicle unique. IP address unique. So we already have objects which are already normalized. So we don't perform normalization in object-oriented. We do in structured. So for internal schema, after we have done the logical schema, what we do? We physically create the database, tables, fields. We have done the architecture, the documentation part. We know these are the schema name, these are the table name, these are the fields. Done. This is what we need to physically go to the tool like SQL Server, Oracle, Access, MySQL. So we create database, we create tables, we create fields, we set the primary key. Done. So our physical internal or physical schema done. That we do physically create database, tables and fields. But what technique we use? We are covering techniques. What technique we use to do this? Yeah, to create database, tables, fields. What technique? We are covering technique. Like we say, normalization is a technique. So what technique we use to create? You have graphical user interface and command line interface. In the command line, how we do? In database, how we do? We have SQL, SQL language. And for graphical, we have query by example interface. So in Microsoft SQL Server, in Access, there is a graphical user interface, query by example. Click here, click there, database is there, tables are there. Type the field. Command line, which is SQL, SQL, and GUI, which we call QBE, query by example. SQL and PLSQL is there. PLSQL. Then we have external, so we don't need, because it's a view. We use command line or we have GUI. any other technique in the design phase. We have to create our screens, interfaces, forms, reports. So we have technique for to create interfaces, interface designing. Interface designing. What technique we use to create our screens? How to create? Again, CLI and GUI technique. You have framework like .NET, NetBeans. Interfaces are there. Graphical user interface or command line. These are the technique we have. Visual Studio .NET. You have interfaces there. You go to the framework, design your interfaces, drag and drop. Graphical user interface, and CLI is there to design your interface. Again, CLI and GUI. Any other technique? We have hierarchical charts. Hierarchical charts are like organizational charts. Like we have president of King Abdullah University, we have vice presidents, we have deans, vice deans, chairman, professor, hierarchy. That we have top to down. We show all hierarchy. So why we use hierarchical chart technique? It's a technique. What is the function, purpose of hierarchical chart? To have functional decomposition, to divide the main functions into smaller functions. Divide and conquer approach, modularity, modular approach, modules, like you have Hotmail, email system, inbox, junk, compose, send message, trash, then under inbox, compose, send message, trash. So you divide the functions like in PowerPoint. You have file menu, you have insert menu, home menu, design, transition, animation, slideshow, review. Same in Word, same in Excel, same in Visual Studio .NET, NetBeans in the menu bar. Or you go to the ATM, you have transaction menu, you can withdraw, transfer cash, check balance, pay bill. Modules are there. And under each module, you have sub-function. So if you write, you need so many pages, written description. So graphically, it's easy. And in compressed way, you can show all functional decomposition or stepwise refinement using hierarchical chart technique to have modularity. What are the main modules? What are the sub-modules? Main function, sub-function. And in one view, glance, you can see. It's very easy for you that you divide the problem into small pieces, chunks, easy to handle, easy to manage, easy to assign tasks to the programmers. Complex modules you can assign to senior programmers, easy module to the junior programmers. Easy to track the project, how much you have completed, how much left, how many functions completed, how much left. So you divide the problem from top to down, up to most linear level that you cannot further divide it. Simplify it. That's also design phase technique. Then you have algorithm designing technique. Algorithm designing technique. Algorithm designing. How many algorithm designing techniques we have? Your reaction is like that. I'm asking to a medical science student or earth science student, or I'm talking about Marikh, Mars, Moon, aliens, black hole. How I know? Then who knows? Anyone? We have 5 types of algorithm designing techniques. We have pseudocode, flowchart, decision table, decision tree, NS diagram. NS is a scientist name, Nessie Schedelman. But flowchart is the most widely used technique because again graphical, it's easy to draw, time saving. Otherwise pseudocode, English statements you keep on writing, and if you have 30,000 lines, you will die in a 30,000 lines, 2,000 lines, 100,000 lines. So he will die. The guy who is doing the pseudocode or the team who is doing, it's very complex. It's not 300 pages or 400 pages. So flowchart is the most widely used. These are the all algorithm designing techniques, design phase techniques I covered. Any question up to here? Now we have implementation phase. So I'm moving now. Implementation phase is a generic name for all methodologies. Implementation phase. So what we have under the implementation, we have done design. Now we do coding. So we have coding techniques. How many coding techniques we have? Programming techniques. Coding means programming.
Yes.
So what programming techniques we have? How many programming techniques we have?
I do remember there is rapid programming. In 250, we took that.
With programming?
Fast programming.
Fast program, rapid program, rapid program.
Yes.
This is a technique.
I do think so.
You pass CPS 202, 203. I taught these courses because I know 204. And now you are saying we have only rapid programming technique?
Before that.
Huh?
Before that.
For nothing remember.
Nothing.
Blank, hard disk formatted.
Yeah.
Because of Corona or any other reason? We have 4 techniques. We have structured programming, we have object-oriented programming, we have declarative programming, we have event-driven programming. This is your ABC as an IT student. You cannot forget. Like you forget your name if you forget them. Without programming, we are nothing as an IT professional. OO, event driven, and 4th, declarative. Structure. How to define structured program?
Like, yeah.
I'm not asking like, I'm asking how to define. What is the concept? And Java is not structured programming language. Structured programming use 3 approaches further. We have top-down, modular, and control structure approach to write programs. Top-down, modular, we already covered in design. The hierarchical charts I just erased. We look the problem from top to down and we divide it in modules, in chunks, in pieces, in procedures. Now comes to the control structure. Control structure approach was introduced in 1960s. If I'm not mistaken, 63, 64. 63, 64. That all programs can be written using sequence, selection, and repetition. All programs can be written using sequence, selection, and repetition. Sequence, selection, and repetition. What is the meaning of sequence? Okay, I rephrase my question. How many steps are there to write code? How many steps are there to write code? How many have worked on C, C++? Okay. How many steps are there to write code? There are 4 steps to write code. I am telling you the key. Variable declaration, declare your variable, step number 1. Step number 1, declare your variables. Step number 2, input instructions. Step number 2, input instructions, write input instructions. Step number 3, write processing instructions. Processing instructions. Step number 4, output instructions. Khalas, that's it. This is what we need. We already declare our variables. We have input instruction. We have processing instruction. We have output instruction. Done. There are 4 steps to write code. And as per the scientists, their names were Baum and Jacobini, if I am not mistaken. These 2 scientists introduced this idea of sequence, selection, repetition, control structure approach. We call it control structure approach. That in structured programming, you have to follow a sequence. You have to follow an order. Step 1, declare variable. Step 2, input instruction. Step 3, processing. Step 4, output. You cannot change the sequence. You cannot change the order. That output instruction number 1, variable last, processing number 2, input 3. No. Your program will not work if you try this order. You have to follow the order. Variable, input, processing, out. Then your program will work. So for all structured programming languages, C, C++, Cabol, Pascal, Fortran, these all are structured programming languages. So you have to follow the order. You have to follow the sequence. Like you cannot take 251 without passing 250. It's prerequisite. You must have to take it. You cannot take 252 without passing 251. And your software engineering track course is 455, 456. You cannot pass a register until you pass 251. Order is there. We have prerequisites. Same in the structured programming. Prerequisite, you have to follow the sequence. Selection. Sequence done. Selection. What is selection? If else structure. If average is greater than 95, A plus. If average is greater than 90, A greater than 80, 85, B plus, B, C plus, C less than 60, fail. So we have if else structure, we have switch case structure or select case structure in Visual Basic. Select case, switch case, if else, this is selection. To have selection between or among the things. And we need that. And then you have repetition, loop structure. We also call them iteration. Repetition, loop, these all are the alternative names we use. So we have while, when, do while, for next, for loop, do while loop, do until loop. So we have so many. To repeat the instruction again and again instead of writing again and again, use loop. And when you want to terminate the loop, termination point, exit from the loop.
In the sequence, there is like a process structure, right? We can't use the selection and repetition in it, or how?
Again?
In the sequence, there is a process structure.
Processing instruction.
Yeah.
Yes, like formula, like sum is equal to num1 plus num2.
Isn't the if and the selection and repetition in it, or how?
Like if it is addition program, you don't need if else. But if it is grading program, you will calculate the total average and then you use the if else structure. So it's not essentially use all of them. But these are structured programming. You can use sequence, you can use selection, you can use repetition. But this is the combination of the three approaches is structured programming. You will use sequence, selection and repetition if you need. Otherwise, for example, if I just need to calculate sum, you don't need to have if else structure. Only addition. But if it is grading program, you need if else structure or select case, switch case structure. And if you want to take multiple inputs, input first subject, input second subject, why we need so many instructions? So I just need one instruction to take input of, assign it to another variable and then take the second input. Like if there are 10 subjects, 5 subjects, 20 subjects, just one instruction, assign it to another variable and then take second input, then third and then so on. So we don't need unnecessary input instructions and then we have to assign them variables. So we repeat the same instruction until we terminate the loop. Like count 1 to 100 or 1 to 1000. Why we have so many instructions? Got it? Any question regarding structure programming? Then we have how to define object-oriented programming. You all are feeling cold.
It's called.
I can't help you in this regard. Helpless.
It's okay.
So, how to define object-oriented programming?
Programming driven by objects.
Very good. It's a way of writing program using objects to perform specific tasks. What is an object? How to define object?
It's an object.
Object is an object. I was in an interview for some job of professorship, and there was a panel sitting in front of me, big guns are there, there was a big table, a machine guy sitting on the other side, and they were having faces, very tough, tight faces, and there was one guy from, he was the chief executive of software company, one professor from top university, and then there was the head of that university, and there are some other people sitting. And the software industry guy, the chief executive, he asked me, if you have to explain to 5-year kid who doesn't know programming, 5-year kid, it's a stupid question. 5-year kid, what is an object? How you will explain? 5-year kid doesn't know programming, but you have to explain him what is an object. Should I say object is an object?
No.
Cannot. Object is a combination of data and methods or functions into a single entity that is uniquely identified. This is high level. But what I answered there, I said, I will ask that kid, 5-year kid, what's your name? What is your father's name? What is your contact address? This is your data. Your data or attributes. And what are your actions or reactions? These are your methods or functions. Eating, simple. He will understand. He eats. Sleeping, he sleeps. Running, walking, he does that. So that is your functions or method. So you are an object. And you are unique. There are no other kid like you in this whole universe. Your fingerprints are different. Your iris are different. Your birth ID is different. That is your unique data, and you have actions, reactions. These are your functions or methods. So you are an object. That's the object programming. Simple. That is the answer for the kid. But for our level, for technically, object is a combination of data and methods into a single entity that is uniquely identified, like student ID, citizen ID, DNA, fingerprints, iris, as I just said, car, vehicle, unique, computer, unique, IP address, unique, your mobile phone has unique serial number. Your projector screen has unique number. Your classroom has a unique number. There is no 8A in this whole FCI. Okay? And there is no TPID 2515D. There is no other section 5D. It's unique. So that's the object-oriented programming. Now, what are the techniques we have in object-oriented programming? This just we understood that what is an object-oriented programming, and class is a collection of objects. Class is a collection of objects. How many techniques we have in object-oriented programming? We have instances. We have constructor. We have method overloading or function overloading, overriding, abstraction. These are the techniques available in object-oriented programming. Instance. We have object. How many phases are there in the life of an object? Then we understand what is an instance technique. SDLC phases of an object. This is very conceptual, which is the foundation of object-oriented programming, under which object-oriented programming is designed. How many life cycle SDLC phases? Like we have SDLC phases of methodologies. Similarly, object has SDLC. Anyone? Object programming is designed on the SDLC of human being. We, humans. How many life cycle we have? We have logical phase and physical phase. Allah has created spirits, root of all human beings at the beginning. So our logical phase is declared. And when we born, when a human being born, it is his physical phase. Now he has ID, citizen ID, his gender, male or female, father name, mother name, his contact, his address. Spirit has no name, spirit has no age, spirit has no contact. I cannot call the spirit to sit in my lecture. I can call jinn to sit in my lecture, but I cannot call a spirit to sit in my lecture and take exam of 38251 and explain me what are the techniques, programming techniques, structure programming, object programming. Can I? No. And then human being die. Very nice. Again back to logical phase. Again back to logical phase. Same is the object-oriented programming. When you declare data and methods of class, when you declare data and method inside a class, it is the logical phase of an object. You cannot call the data, you cannot call the method. And then in the main method, public static void main, you create class name space obj1 is equal to new class name. Now obj1, you create the object. Now you can call the data and methods obj1.set, obj1.compute, obj1.show, obj1.execute, exit. Now we can perform, we can call the methods we declare, and then we can execute them. We can perform the function. So same human being, when he is born, then you can call him to perform some job like come here, raise the board. What's your name? Said. Mr. Said, I use his data to perform an action, to make a change in his state. Come and raise the board, or set the projector, or call the technician to reduce the temperature of this classroom so we feel comfortable. To make, I use the data of an object to make a change in his state. But it is possible when he is there, he is born, he is physical. I cannot call to the logical spirit. That is the physical phase of an object. Like log, object. Log, why we use log on? To authenticate username and the password, to authenticate the user, to validate. Once it's done, log object job is done. Again, logical. And we have the main menu, form is there, like registration form or transaction menu. And if we don't use it for a while, our session will expire. There is a session time. Our session will expire, then you have to refresh the page. And again, the log object will be called. And from logical, again physical. Again authenticate username, password. If you have not saved, you have to enter again. Otherwise, it will take from the cookie. And validate, and then again login, and form menu is there. So logical, physical, again back to logical, like human being. You have logical, physical, again die, again back to the logical. That is instance programming. When you create object is an instance of a class. You can create as many objects, obj1, obj2, obj3, command 1, command 2, command 3, text box 1, text box 2, text box 3, label box 1, label box 2, label box 3, as many as we want. Like in the toolbox, you have command, components are there, drag and drop. So, command 1, command 2, command 3, form 1, form 2, form 3, max of word, doc 1, doc 2, doc 3, as many as you want, as required. That is instance of a class. Occurrence, instance means occurrence of a class. And then you have constructor. What is constructor?
It's like the default object.
Constructor has some unique properties. Constructor has some unique properties. As you are saying, constructor has the same name as the class name and the program name. Constructor is initialized by itself. You don't need to call it. As you execute the program, constructor will be initialized by default.
When you create an object.
Yeah. And it has no return value. It doesn't return value, it has no return value. So these are the three unique properties of constructor. Then you have method overloading or function overloading.
Creating method with the same name,
Yes.
but different attributes.
When two or more methods have the same name but different parameters or different data types. different parameters or different data types like int num1, int num2, float num1, float num2. We have two parameters, but data types are different, or single, long, double. Or we can have like some int num1, int num2, and we have some int num1, int num2, int num3. Now we have three parameters. So one sum or compute has two parameters, one compute has three parameters. Or their data types are different or parameters are different. So we don't need to remember too many method names, function names. If we are doing some like addition, one compute for addition, plus, minus, multiply, divide. So compute is the same, but and then you have function overriding or method overriding. This is inheritance. Overriding superclass features. So you have parent class or superclass and you have child classes. Like you inherit features of your forefathers from mother side and father side up to 7 generations. Medical science proved that up to 7 generations. So you inherit features of your forefathers up to 7 generations from mother side and the father side. And you are the best of the best from those 7 generations. Because Allah has created human beings like that. So you have the best of the best. Just for the survival. Only the best one will survive. Weaker will die. Stronger will survive. Fittest for the survival. Like in old age, people die. Or in corona, weak people are more affected, whose immune system is weak. Whose immune system is weak. Strong people survive, whose immune system is strong. Like in jungle, only strong animal will survive. Weak will die, even he is a tiger or elephant or anyone, any animal. Weaker will not survive. Like in the winter season, only strong, powerful will survive. Weaker will die with cold, with hunger. So nature doesn't forgive you. Don't play with nature. This is us.
Can I leave our class in 10 minutes?
Why?
I have a class in 10 minutes. Can I leave?
What time we are finishing?
Yes.
9:20.
9:20.
So how much time left?
10 minutes. My other class will start at 9:30.
What is the time now?
9:20. 9:20.
Okay. So I finish here. Any question about today's lecture? So we all will leave. I will leave.
I'm feeling so cold. The sun.
Any question about today's lecture?
No.
Okay. Thank you very much. Jazakallah khair. May Allah bless you. See you inshallah in the next lecture. And be prepared for